Hello everyone, welcome to today's session. Today we are going to discuss solutions to the numerical of exercise 2A of your Concise physics textbook. So without any delay, let us go to the questions. We will start with the question number 1 of exercise 2A. Look at the screen and read the question thoroughly. A body when acted upon by a force of 10 kg force gets displaced by 0.5 meter. Calculate the work done by the force when the displacement is in the direction of the force and at an angle of 60 degree with the force, and third, normal to the force. And the value of G is 10 Newton per kilogram. So whenever you get a question, read the question, understand it, and what all data are given there, please note down it. A body when acted upon by a force of 10 kilogram force. The force is 10 kgf. So what you have to do? You have to do the necessary conversion into SI system. 10 kilogram force is equal to 10 into 10, that is 100 Newton force. Clear? So we have done the conversion. Get displaced by 0.5 meter. So displacement is equal to S is equal to 0.5 meter. Okay. Calculate the work done by the force when the displacement is in the direction of force. So what is the work done when the force is acting in the direction of the displacement? What is the formula? Work done is equal to force into displacement. You know that. So force is equal to 100 Newton into 0.5 meter. So what is the work done in the direction of force? That's equal to 100 into 0.5, that is equal to 50. What is the unit of work done? 50 joule. Correct. Write the correct unit. Okay. So that's the first part. Moving on to the second part. At an angle 60 degree. So work done is at an angle of 60 degree. Okay. So when the force is at an angle of 60 degree, what is the formula used? W is equal to Fs cos theta, where theta is equal to 60 degree. Alright. So W is equal to force. What is the value of force? 100 Newton into what is the displacement? 0.5 into cos 60. Cos 60. What's the value of cos 60? Get it from the logarithmic table. It is coming out to be 100 Newton into 0.5 into 1 by 2. The value of cos 60. So that's equal to, cancelling 50 into 0.5. We are getting it as 25 joule. Alright. So 25 joule. The third part of the question is the work done when normal to the force. So what is the work done when the force is acting at an angle? Here theta is equal to normal, that is 90 degree. Alright. So when the force is acting normal to the force, work done is equal to Fs cos theta. W is equal to force is 100 into displacement S is equal to 0.5 into cos 90. What's the value of cos 90 here? Cos theta, cos 90. Cos 90 is 0. Therefore, W is equal to 100 into 0.5 into 0. So that we are getting it as 0. So we are getting the work done as 0 when the displacement is normal to the direction of the force. Is that clear? Okay. Moving on to question number 2. Look at the screen. A boy of mass 40 kg climbs up the stairs and reaches the roof at a height 8 meter in 5 seconds. Calculate the force of gravity acting on the body. Second, the work done by him against the force of gravity. Third, the power spent by the boy. So a boy of mass 40 kg. So mass is given as 40 kg. So write the mass. Climbs up the stairs and reaches the roof at a height of 8 meter. So the height is equal to the displacement. It's going up, that is 8 meter. What is the time given? Time given is 5 seconds. Okay. Clear? These are the data given. The first part. What do you have to calculate here? The force of gravity acting on the body. So remember the formula for force. Force is equal to mass into acceleration due to gravity. Since the boy is going up, A will be replaced by G. Therefore, F is equal to mg. The value of G is given as how much? 10 meter per second square. It is given. Therefore, we can write mass is 40 into 10, that's equal to 400 Newton. SI unit of force being Newton. Clear? Now the second part of the question, the work done by him against the force of gravity. So the work done is equal to, we know the formula, force into displacement. So what is force here? Force is equal to mg. We know mg. S is equal to h. So mgh. So that's equal to. So what is mg? We are got the value of mg 400. Correct? 400 into h. What is height? H given there 8 meter. So put the value of height. So we are getting it as 400 into 8. How much it is? 3200 joule. Unit of work done. Now the third part of the question. So what is the third part of the question? The power spent by the boy. So what's the formula for power? How much power the boy spends in going up through a distance of 8 meter? Power is equal to rate of doing work. You know the formula. Power is equal to W by T, work done upon time. So what's the work done given there? We have found out the work done. Put the value of work done there, 3200 divided by, what is the value of time there? 5 seconds. So 3200 divided by 5. How much we are getting? That's equal to 640 joule per second, right? Joule per second is watt. So what's the power spent by the boy? 640 watt. Is that clear? If you know the formula, these are some kind of direct substitution questions. You can directly put the value and get the answer. Now question number 3. A man spends 6.4 kilojoule energy in displacing a body by 64 meter in the direction in which he applies a force in 2.5 seconds. Calculate the force applied. Second, the power spent in horsepower by the man. So what are the data given? So a man spends 6.4 kilojoule of energy. So energy is given. So energy is nothing but it is the work done. Energy is equal to work done, that's equal to 6.4 kilojoule. Alright, 6.4 kilojoule, that I can write 6.4 into 10 to the power 3 joule. Alright, I have converted kilojoule into joule. Okay. Now the displacement, distance mode is how much? 64 meter. 64 meter. And the time given is 2.5 second. Am I correct? Okay. So what do you have to find out there? The force applied. So we know the formula. Work done is equal to force into displacement. Correct? So work done is equal to 6.4 into 10 to the power 3 joule is equal to force. We don't know. Let it be as F into displacement is 64. Therefore, F is coming out 6.4 into 10 to the power 3 divided by 64. So that's coming out to be 10 cancels. So 10 into 10 square. So we are getting it as 100 Newton. Clear? So we are getting the value of force as 100 Newton. So that's the first part. The second part of the question. What's the second part of this question? The power spent in horsepower by the man. So the power is equal to rate of doing work. Write the formula W by T. So what's the work done? 6.4 into 10 to the power 3 divided by time is 2.5. Just to solve it, divide and see. You are the answer comes out to be 2560 watt. 2560 watt. So that's the answer. So you have to convert the watt in express it in horsepower, another unit of power. So 2500 you know that 1 horsepower is equal to 1 HP is equal to 746 watt. Therefore we can write the answer 2560 divided by value of 1 HP, that is 746 watt. So that we are getting it as divide and see the answer comes out to be 3.43 horsepower, HP, horsepower. So clear? Is that okay? Fine. Moving on to question number 4. A weightlifter lifted a load of 200 kilogram force to a height of 2.5 meter in 5 seconds. Calculate the work done. Second, the power developed by him. Take the value of G as 10 Newton per kg. So read the question and find out the quantities given over there. A weightlifter lifted a load of 200 kilogram force. So load is nothing but it is the force. Force is given in 200 kgf. That's the gravitational unit of force. Convert into SI unit of force by multiplying it by 10. 200 multiplied by 10, we are getting it as 2000 Newton. So we have done the necessary conversions. Now to a height of 2 point, height is equal to S, that is the displacement, 2.5 meter in 5 seconds. Time is also given there as 5 seconds. So we have found out all the quantities given there. Calculate the work done. The first part, work done is equal to force into displacement. So that's equal to force 2000 Newton multiplied by what is the displacement, that is equal to 2.5 meter. Correct? Yes. So that we are coming out as 5000 joule. So that's the work done. Clear? Second part. What is second part? The power developed by him. Power developed by the weightlifter. So power is equal to, you know the formula, rate of doing work, W by T. Work done we have already calculated. Place the value of work done over there, 5000 joule divided by, what is the time? 5 seconds. So cancel it. So we are getting it as 1000 joule per second. Joule per second is nothing but it is watt. So 1000 watt. Clear? Okay. Now moving on to the last question of this session, question number 5. A machine raises a load of 750 Newton through a height of 16 meter in 5 seconds. Calculate the energy spent by the machine, the power of the machine if it is 100% efficient. So a machine raises a load of, so what is the force? Load is nothing but it is force. Remember that. Force is equal to 750 Newton. So there is no need of any conversion. It is given in SI unit through a height of H is equal to S, displacement 16 meter in 5 seconds. Time is equal to 5 seconds. Calculate the energy spent by the machine. Energy is nothing but energy. So energy is nothing but it is the work done. Remember, energy is nothing but it is the work done. Force into displacement. So force is 750 Newton into displacement, that is 16 meter. The answer comes out to be 750 multiplied by 16, 12,000 joule. Okay, that's the first part of the question. The second part, in the second part you have to calculate the power of the machine. If its efficiency is 100%, so there is 100% efficiency, there is no loss of energy, so power is equal to rate of doing work, W by T. Work done we have already calculated. Place the value of work done over there, 12,000 joule divided by time. What is time? Is 5 seconds. So cancel it and see 12,000 divided by 5. We are getting it as 2,400 joule per second. What is this? The unit is watt. Okay, so we got the solution to the question number 5. So remember and learn all the formulas, practice the formulas by applying it in numericals. Daily practice is required for numericals so that you can master over the applications, I mean numericals in physics. So that's the wrap up for today. Thanks for watching.